Okay, good morning, math students. Here we go. Remote learning lesson number 1. So here's what I'm going to do. I'm going to make a note page similar to this for every lesson and send you the link. So you have two options. You can either print out the note page and follow along with what I'm doing, or you can just get a piece of notebook paper. It's a piece of regular paper and just follow along that way. Either way you want to do it is fine. I just want to make sure that you're actually taking the notes because I'm expecting that we will hand them in at some point. So make sure you take the notes. And okay, here we go. This is weird for me because I'm sitting in this empty classroom talking to myself. And yeah, I was gonna bring my dog, but he barks a lot, so I thought that would be annoying. Okay, here we go. This gray section right here is just the state standard for each lesson. It's basically just for me to help me keep track of what I'm on. You don't need to pay any attention to that if you don't want to. So right here it says essential question. This is what we're going to be working on today. So get your pencil, follow along. How do I know the distance between 2 points if they are not vertical or horizontal? So how do I know the distance between 2 points if they're not vertical or horizontal? Basically, how do you find the distance between 2 points that are diagonal from each other? So it's diagonal lines we're worried about. So a vertical line would look like this. Let's say you have a point at 5 on the y and at -2 on the y. This is easy to figure out how far apart those two dots are, those 2 points are, because it's on a graph and we can just count it. So there's 5 here and then 2 more. So the distance, which is a little d, the distance is 7. The 5 and then the 2. That would be a vertical line, easy. Horizontal line, let's say we have one at -5 and 1. Find the distance between those. You're just going to say, well, there's 5 right here till we get to the y-axis, and then 1 more. 5 and 1 is 6. So distance on that one is 6. But we're trying to learn or figure out how to do it for a diagonal line. So let's say you have a point right here at -4 and 0. And then you have another point at 2 and 5. And we're looking for that distance. You can't count it like you did the other. We've got to do it another way. So, and I think on the one I printed out, there's not that extra square. I must have printed out the wrong version. Anyway, no big deal. Ignore this. Okay, so the way we're going to figure out the distance, we're not going to count it. We're going to use the Pythagorean theorem. So write that right here. Use the Pythagorean, Pythagorean, Pythagorean theorem. So Pythagorean theorem, you guys learned in 8th grade. But it's been a minute since you've been in 8th grade, so maybe you're a little rusty on it. So that's why we're going over it today. So hopefully you remember this. A squared plus b squared equals c squared. Hopefully that's ringing a bell. Also, hopefully you're remembering that when you use the Pythagorean theorem, it has to be a right triangle. So draw a right triangle. All three sides of the right triangle have a name. The two sides that come directly out from the 90-degree angle are called the legs. And then the side that is across from the 90-degree angle is called the hypotenuse. 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 And it's good to remember the hypotenuse is always the longest side.
Mrs. Larson, please come to the front office. Mrs. Larson.
Well, there you go. That proves I'm actually in school. Okay, so Pythagorean theorem. Remember I said it has to be a right triangle. We've got two legs and a hypotenuse. The legs, they give an a or a b variable too. It doesn't matter which is which. This leg could be a, this leg could be b, or it could be reversed. It doesn't matter. The most important part is the hypotenuse is always c. So on your formula, think of it this way. The a is a leg squared plus the b is the other leg squared, and the c always is that diagonal side, the longest side, the hypotenuse. I'm just going to put HYP squared. Okay, hypotenuse squared. So hopefully that's ringing a bell. Now I lost the back side of this page. Hold on. Oh wow, this is embarrassing. Where the heck did that go? Oh, here it is. Okay. So, back side of the page. Pythagorean theorem, just a review from 8th grade. But like I said, it's been a minute since you were in 8th grade, so this might be a little bit rusty. So here we go. Draw a right triangle. Remember that little square in the corner is a designation that says it's a right triangle. We're going to call one leg 4 and one leg 3, and we're trying to find the hypotenuse, which remember they use the letter C. The hypotenuse is across from the right angle. So, okay, let's write this back up here so we have a reference. Right, a squared plus b squared equals c squared. The a is a leg squared plus the b is another leg squared equals the c is the hypotenuse squared. All right, so now we go back to our triangle. We're saying, okay, we have a leg that's 4, so 4 squared plus another leg that's 3, so 3 squared equals the hypotenuse squared. So the tricky part of this is we don't want to know what the hypotenuse squared is, we just want to know what the hypotenuse is. So I know we've talked about this before, but maybe you've forgotten. How do you reverse when something's squared? What's the opposite operation when something's squared? Well, you square root it. Square root both sides. So if I square root this side and I square root this side, this square root and that square cancel each other out. So now I'm going to find out what c squared is. And I'm actually going to write it the other direction so it looks a little bit better. I'm going to write c equals, which is the hypotenuse, the square root of the leg squared plus the other leg squared. All right, so this is where I'm hoping you all have a calculator or a phone, because your phone will do this too. And I'm just going to type it in just like that. Square root 4 squared plus 3 squared. Hit enter, and it tells me the hypotenuse is 5. Which, remember I told you the hypotenuse always has to be the longest side. So 5 is bigger than 3 and 4. So I'm pretty confident in my answer. Okay, let's do another one with the triangle facing a different way, because I don't want you to get used to the triangle always facing the same direction. So draw a right triangle, kind of going that way. We're going to make one leg a 2, the other leg a 5. And remember, it's the diagonal side we want, which is the hypotenuse. So here we go. We have leg squared, which is 2 squared, plus the other leg squared, which is 5 squared, equals the c squared. Now we don't want the c squared. We just want to know what c is. So we're going to square root both sides. And that square root and that square cancel each other out. And I'm going to reverse the way it's written. So I have c squared equals the square root of 2 squared plus 5 squared, which is the 2 legs. So grab your calculator. You're going to do square root of 2 squared plus 5 squared. Hit enter. And the answer is 5.38, on and on and on. Now, when you do your homework, I've asked you to round everything to the nearest tenth, which means you only need 1 decimal place. So 5.3, I'm looking at the 3 to see if I'm going to leave it the same or round it up. Since the 8 is big enough, it's bigger than a 5, it bumps the 3 to a 4. So 5.4 is the way you're going to do this on your homework. The homework's in Schoology, and your answer has to match mine exactly, so try not to round it wrong. Okay, we're gonna do one more. So this time I want you to turn the triangle this way, just so you get used to the fact that these right triangles can face many different ways. The short leg, call it 3. The long leg, call it 10. Oh, I forgot to mention something over here. The triangle right before. Our legs were 2 and 5. You have to make sure your hypotenuse is longer, and ours is 5.4. So it's longer. That's perfect. Okay, here we go on this one. We have leg squared, so 3 squared, plus the other leg squared, 10 squared, equals the c squared. The c is the hypotenuse directly across the right angle. Now we're going to square root both sides, because the square root and the square will cancel each other out. And then we're going to have c equals square root of 3 squared plus 10 squared equals square root of 3 squared plus 10 squared equals 10.44. So I'm just going to write it as 10.4 because we're rounding to the nearest tenth. So 10.4 And check to make sure your hypotenuse is longer than your legs, and it is, so we're good. Okay, that's all we're gonna practice. Here, because every single time we take the square root of both sides, in my mind, I just cut to the chase and just kind of shorten the way I go about it, because I know I'm gonna square root every single time. So this is the way I think about it. If I want the hypotenuse, which is the diagonal side, I know I'm every time gonna do the square root of the leg squared plus the other leg squared. So this is the way I think about it when I'm doing these problems. Okay, so to answer our essential question, write this sentence right here. To find the length of a diagonal line, make a right triangle. And then use your Pythagorean theorem. So, example right here. Let's say you have a point at -3 and, -3, 0, and 1, 2. We need to know that distance. You are going to turn this into a right triangle. I'm going to go up, and I'm going to go over. That was really messy, sorry about that. Turn that into a right triangle. Now we can use the Pythagorean theorem that we've been working on. So this diagonal line is going to be this leg, which I can see as 2 squares, and this leg, 1, 2, 3, 4 squares. So there's my legs. So the hypotenuse equals the square root of the first leg, which is 2 squared, plus the second leg, which is 4 squared. And that will be the distance between those. So square root 2 squared plus 4 squared, enter, is 4.47. The 7's big enough to round the 4 up to a 5. So the answer is 4.5. So the distance between this dot and that dot is a 4.5. So distance equals 4.5. And the 4.5 is bigger than my 2 legs. So I'm good to go. Okay, let's do another one. Say you have a point at -3, 4, and 1, -1. And we're asked to find the distance between those 2 points. So you're going to turn it into a right triangle. Try not to do that one so messy. Okay, figure out how long the legs are. This leg, 1, 2, 3, 4, 5. That leg's a 5. This leg, 1, 2, 3, 4. All right, to find the distance, we're going to find the hypotenuse. So hypotenuse equals square root of 5 squared plus 4 squared. Remember, we're rounding to the nearest tenth. Square root of 5 squared plus 4 squared, enter, is 6.4. So the distance between those 2 points, which is our hypotenuse, is 6.4. And you want to make sure the 6.4 is bigger than the 2 legs, and it is. So we're good to go. Okay, one more, and we're done. let's say we have a point at 2, 4, and we have a point at -2, 0. We need to find the distance between those 2 points. Turn into a right triangle. Find out how long the legs are. This leg is 1, 2, 3, 4. This leg is 1, 2, 3, 4. And we want to find the distance between them, which is the hypotenuse. So hypotenuse equals square root of 4 squared plus 4 squared. Stick that in your calculator or your phone or whatever you're using. 4 squared plus 4 squared, enter, is 5.65. So I'm going to round that up to 5.7. So the distance between those points is 5.7. And it makes sense because the 5 is bigger than either of the 4s. Okay, so that's a review of Pythagorean theorem from 8th grade. Your homework assignment is on Schoology at washk12.org. Make sure when you do this, you put the at washk12.org because that's where your account is. So go to Schoology. I think there's 6 problems, and I would like them due by Friday. Thank you. Have a great day in your house all by yourself. Bye.